So far we have covered how to use the variables inside a 8086 emulator. Now we will be focusing on arrays. How do we define array? And defining array is exactly like defining a variable. So we have to write write the values of array under the rate command. And for example, this small code means there is an array, is a byte type array, so it can contain byte data inside it. This array is called A, and the values are 5, 7, 3, 6, 8, and 1. So it's a length of 6. The length of this array is 6. So I can iterate in this array. So how do I do that? Let's say I can right now I do not need this part anymore, so I can erase this small part as well. So if I store something inside segment index register, let's say 0, and I move value of a si means a0 to al, then if I press emulate and take single step, what it's gonna do is gonna take the value of a0, because si is containing 0 right now. Si is containing 0 right now. So it will take the first value from the array and place it inside al. So al is containing nothing right now. So if I press one more step, and it will contain 5, because segment index si had 0 in it, and a0 means 5. So what if I increase the value of si? Say let's say increment si again, and write this line once more. And I press emulate. So single step, so it's containing right now si is containing 0. So I press one more step, and si is containing still zeros, and this a0 was 5, so ax got 5. Then increment si will be called. So if I take one more step, the value of si will become 1. So it will now locate 7h, because a0 was 5, a1 is 7, and this will be stored in al when I press one more step. So al is getting 7 now. So we can iterate inside this array. So how about we make a loop that will go through the array? And how do I do it? We can use jump command, we can use unconditional jump, and we can use conditional jump as well to stop a loop. So how so we can so first of all, I'm gonna show you how to make a unconditional jump. So how do I do it? 2 steps. One, first of all, I have to make a level. This level is called here, and after finishing this part, let me erase this part as well, because this part will be repeated. So after finishing this part, this program will jump to here. So what it's gonna do, the program will start, then it will come here, then the 0 will be stored in si, and if I do that, then 0 will be assigned every time we come here. So we are defining si 0 at the beginning of the code, because we don't want si to get 0 every time we come here. So after coming inside the here level, we are going to take the value of a0 and put it inside al. Then we can call increment command on si. So value of si will increase. So on the first loop, si will be 0. When it will reach here, it will jump back to there, that means here, and this will locate 7h instead of 5h, because value of si has increased. So let's try emulating this code. So we take single step. Now take a look at si. It's containing 0, 0, and value of al is also 0. Now we are here, and si is still 0, so a0 is 5, so al will get 5. Al has found 5. then we press one more step, so it says jump here, so this will jump back to there. So jump back to here, and this time SI has 1, so array 1 means 7, so AL will get 7 after press one more step. Yes, array 1 got 7, and the next step is gonna go to jump here, and it will jump back to there, and SI will get 3 this time, 2 this time. So is going to take the value of array 2, which is 3, and it went inside AL as well. So if I keep pressing single step, it will contain every value inside the array till it gets 1, and the last value was 1, so it will get 1 as well. Then it will get some value, which means there is nothing inside the array, so it will go to the blank state. So on the next step, we want this loop to stop. We don't want this loop to go on forever and ever. And how do I do it? We can use a very small command called compare values. So how do I compare values? We have to write a small code called CMP, and we will check the value of SI. Look at the length of this array. It's 1, 2, 3, 4, 5, 6. So this is an array of 6 values inside it. So we have to stop at 6. When the value of SI will become 6, we want this loop to stop. So how do I do it? Well, we have to create a comparison code. So CMP SI with 6. It means we are comparing SI with 6. Now what happens when it becomes equals to 6? We want this loop to stop, we want this command to stop. So we don't if it becomes 0, the zero flag inside this 8086 will turn on. So if it's equal, then 0 flag will turn on, and then the value of JZ, which means jump 0, if the 0 flag is 1, then this will jump somewhere. Let's say we want this ender level. Let's say end level. We want this code to jump to a level called end level, and we are defining end level here. So end LIBEL, end level just end level just contains RET program, so this will stop. So when the value of SI becomes 6, this program will stop automatically. Let's emulate this program. So we are having the value of SI 0, 0. So just take a look at the value of SI. So SI is 1, then 2, 3, 4, 5, 6, and it doesn't go anymore, because after 6 was after the value of SI become equals to 6, it went to end level, and it found the code RET, which means stop the program. The program stopped right at that moment. We can try one more time to make sure everything is going right. So incrementing SI, the value is getting 5, so 5 from here, so still getting 5, I guess. Okay, it's getting 5. Then it should get 7. Value of AX becomes 7, because 7 is here as well, because SI is having the index 1, then 3, then 6, then 8, then 1. So we are iterating inside the array, and we can make something useful out of this iteration. For example, we can get the maximum minimum value inside an array. How do I do it? We have to use another instruction called jump